Hey guys, this is Mr. H. Hey, I am going to do a couple of questions, or about 4 questions from Delta Math. Two are going to be two-step equations, and two are going to be three-step equations. I just created a video where I did this. I did about 4 questions using the traditional inverse operation method of solving equations. Now I'm going to do 4 more equations using boxes and circles. And I want to show you the difference. And I also want to show you why I like to teach this to kids who struggle with algebra, because I think it's more intuitive. All right, so this equation is, we have 89 equals 8c plus 25, and they want us to solve for c. So first thing you're going to do is you're going to box and circle everything up. So in this case, we are going to put 89 in the circle. This is an equal sign. This is going to be 8c. It goes in the box, or the X box. So the variables always go in the box. The constants or the numbers go in the circles. And the idea is circles want to be with circles and boxes want to be with boxes. Kids understand that. They understand that that's intuitive. So I'm going to take this 25 and I'm going to move it to the left-hand side of the equation. The only rule for the boxes and circles is if you move a box or a circle across the line, you have to switch the sign. So if this is a positive 25, when I move it across the line, it's going to be a negative 25. Now that accomplishes the inverse operation. That's technically what we're doing. But for students who struggle with those inverse operations, this is an easier way, a more intuitive way for them to get it. So 89 minus 25 is going to be 64. And then on this side, we're going to have 8c. Now, will be in the circle. This would be in the box. The last thing that I tell my students is that whatever number is left in the box, that's what you divide by. It doesn't matter if it's a decimal, a fraction, whatever it is, whatever the number or the coefficient you're going to divide by. So I'm going to divide both sides by 8. And so I'm going to have 8 equals 1c. So that's my answer for this. I can go ahead and plug that in, submit it, and that's cool. So now let me do another example. I'm going to clear the ink. I'm going to go to the next one. Now, let me get my boxes and circles up there. Okay, so that's it. So now I don't need the box on the right-hand side, so let me get rid of that. So let me get rid of that. All right, so now I'm going to do the same thing I did before. The 79 goes in the box or circle. The 5a goes in the box, the +9. Now notice I always put the sign inside the circle or the box, just because when I move it across the line, I know what to switch it from. Okay, so now I'm going to take this circle just like I did in the previous video, and or in the previous example, and I'm going to move it across the line, and it's going to become a -9. So 79 minus 9 is going to be 70. And then on the right-hand side, we're going to have a, and whatever the coefficient is, that's what we divide by. So it's going to be divided by 5. This is going to be divided by 5. So we're going to have 14 equals 1a. That's our answer. And then I submit it, and we're good. All right, that's it. Now, let's go to the three-step equations. So let me pull up one of those. All right, so let me clear my iPad, and let me get my boxes and circles there. All right, so we got it. So now every term is going to go into a box or circle. So the 4x is going to go in the X box. The -4 is going to go in the circle. The 2x is going to go in the X box, and the +8 is going to go in the circle. Boxes want to be with boxes, circles want to hang with circles. So I'm going to take this 2x, I'm going to move it over here, and I'm going to make it -2x, because it was a positive 2x. When I cross the line, it becomes a negative 2x. And then I'm going to combine those boxes. I'm going to take this circle, and I'm going to move it over here. And if you cross the line, the negative or the -4 becomes a +4. So now all I'm going to do is combine the boxes. So this is going to be 4 minus 2x. So this is going to be 2x on the left-hand side, and 8 plus 4 is going to be 12 on the right-hand side. Last step. Once you get the x's and the numbers on opposite sides, you are going to divide by the coefficient of the variable. And so I've got 1x equals 6. That's our answer. Go here, press 6, submit, Says wonderful job. All right, let's do one more and let's see what we got here. So again, I'm going to get rid of this. I'm going to put my boxes and circles there, and now I'm ready to go. All right, the 5x goes in the box, the X box. The -9 goes in the circle. 6x goes in the X box on the right. The -3 goes in the circle. Boxes go with boxes, so I'm going to take this 6x, move it across the line, and it's going to become a -6x. We're going to combine those. I'm going to take the circle and move it across the line, and now it's going to become a +9. So now on the left-hand side, I have 5 minus 6, which is going to be a -1x. And then on the right-hand side of the equation, I have a -3 plus 9. So this is going to be a +6. So my last step is whatever number is next to the x, or whatever the coefficient of the x term is, I'm going to divide by that. So this is going to be divided by a -1, and this is going to be 6 divided by a -1. This is going to be 1x equals a -6. That's our answer. So now all I have to do is go here and put in a -6 and submit it. And it says, well done. All right, so we're done with this. So I like boxes and circles when I'm teaching students how to solve equations for the first time. I use boxes and circles. The primary reason is it's easier than learning all the inverse operations and all of that stuff. For most kids, it's easy to know what goes into the X box and what goes into the circle. And like once you can get them into the habit of doing that, and once you get everything summed up or boxed up on the left-hand side of the equation and circled up on the left-hand side of the equation, and once you have everything boxed and circled up on the right-hand side of the equation, it's just a matter of moving the boxes or circles across the line. And again, students really get it when you say boxes want to hang with boxes, circles want to be with other circles. They understand that. Now, at some point, you can go back and you can teach the traditional inverse operations, because once they get this method down, you can go ahead and teach them that. To me, the boxes and circles are like training wheels that you have on a bike when you're trying to learn. Once you learn how to ride the bike, get rid of the boxes and circles. And again, you can teach them the inverse operations. Tell them what's going on behind the boxes and circles. But I think this is a pretty powerful tool for students who generally struggle with solving algebraic equations. So I'm going to post this to my channel. So bye.